Right, well, welcome to the LondonCD. Thank you to Alex for inviting me this evening. This is a talk that I did last year. It's called Bending the Rules of SSDT or sqlproj. So does anyone actually use sqlproj or SSDT? Both the same, similar thing? Okay, so this should become familiar to you as we go along. So I was on a client site a few years ago and we came up with a really weird scenario that they actually needed help with. So this is their scenario. They have all these data centers. So this is a client that's in the US, but they are predominantly global. They had data centers in New York, Massachusetts, Texas, and California. But they also had data centers in Hong Kong, Singapore as well. And what we needed to do was we needed to move the data over into a New Jersey data center so we could report on all of the left side of the databases that we had. So what we had is one client had two databases, and they had, when I left, they had 529 clients. So we had to manage the data movements and the schemas for all of those clients. And then on the right-hand side here, you can see that we're moving the New York databases over to the New York data center, or the New Jersey. So that was one scenario. So we had all these different multiple data centers, and we also had the different domain controllers. So you imagine you're on your domain. We had production New York, Texas, Massachusetts, and California. And there were some nuances around that as well, because we had to move it into the New Jersey data center, which was on a different domain. So this is part of the scenario. Imagine you're a customer of us. You want to give us some of your data, and basically we would send out all of your emails. So you imagine those Groupons. Does anyone remember getting loads of them? That was my fault. We sent all of those. We were basically sending out 1 billion emails a day. So one customer, roughly 30 million. Some of the bigger customers, I don't know how they managed it, but they had like 250 million clients. So they'd give us their customer list. So we'd have their customer ID, which was unique to them. Then we'd have the sex, postcode, average spend, and nectar points. You can guess who the client was. This is not how we stored it in our database. So what we ended up doing is we created a new table. So we'd ingest that customer table, and we'd split it out into different tables. So essentially you get a column store, but this was done way before column store came out. So we'd create a primary key, and it'd have an internal identifier to us. Then we'd take each one of those columns and we'd slice it into a new table, and everything would reference back to the internal ID. And as a bonus to this, if any of these didn't have data in, we wouldn't load it. So you wouldn't get nulls, you wouldn't have sparse columns, you just have what is relevant to us. So we saved quite a bit on data as well. So that was one customer. This is a different customer. They have two unique key. They have two columns as their primary key. We do the same thing. We'd create an internal ID, and then we'd split it. So these are some of the numbers that we were looking at. So for every client or customer, we'd have two databases. The tables was the tables times the columns minus the primary keys. So these would give us our objects. So we'd have 529 databases by 2, so you get 1,058. Every customer had a default table, so they get a customer table just to send their emails, and it was 50 columns, so they could fit it into what they wanted, and they'd only have one primary key. But in reality, what we did have was an average of 20 tables and 15 columns, minus 20 primary keys. So this is the total objects that we're trying to look after, and we were doing this every 15 minutes. So we'd have 296,000 objects that we needed to control. So the possible solutions. So the first one was, because we were using SQL Server, we could do log shipping. We had a look at log shipping, but there was a problem. So we could not do log shipping. All the databases were in simple recovery mode. And if you know much about SQL Server, you need to have full recovery mode for the log shipping. So we could not change that. Differential backups. So it was possible for small clients. There were problems for larger clients, so 20 terabytes, disk space, network traffic. So it's the only client I've ever worked with or had a network engineer saying we need more than 10 gigs worth of bandwidth. And the other problem is differential backups could miss data currently being loaded. So the client would have to wait. So differentials, people typically, they'll do them like every hour, every 2 hours, or 4 hours, or 6 hours. So we couldn't use that. Replication works great for smaller clients and when no table changes are made. So a client could always change their tables. Again, we had the problem for larger clients, the disk space, the publisher especially, and the network traffic, because we're moving over quite a lot of data. And new table changes across previous numbers become a nightmare. So if you know anything about replication, you have to go in and you have to select what you want to replicate. And if you want to look after 296,000 objects, it becomes a bit of a pain. The other one was BIML. People kind of said, WTF on that. So no one heard of BIML. People unwilling to learn as it wasn't a Microsoft product. And there were some internal politics around BIML. So the solution, first one is me. So they give me a ring, but it's not that simple. So what we came up with was we wrote our own solution. So we looked at the log shipping, we looked at replication, we even looked at service broker and everything like that as well. So we ended up using the modeling capabilities of DAFX apps. So this is where you model. You can extract, deploy. Then once we've done the extract deploy, we'll move over the data. You can have custom flags for BI and MI. So some people called it BI, some people called it the MI system. I think more of the older guys called it the MI system. You can monitor it easily, so we knew how exactly far behind we were. So we were only ever 15 minutes behind. You can put your feet up with a beer. And you do that. But wait, it wasn't as simple as that. So it wasn't as simple as extracting, deploying, and moving the data. There were different domains caused deployment issues. So does anyone deal with different domains here at the moment? No? So if you imagine you have your different domains, you'd have like IG test / test user. And then you come into production, you'd have IG prod and then / user. That causes a lot of problems in SSDT because you can't variabilize it. So you can't say, give this user this variable and go off and deploy it. The way that SSDT works is it needs to know that user is inside of that pack. So it'll go off and deploy it properly for you. Some objects were broken. Has anyone ever walked into a client or something and everything worked? I've never seen that. So there is something lurking in the background where something's changed over time and there's a column missing in a stored procedure, but no one's executed that stored procedure in 10 years. With SSDT, it comes along and it knows that that is broken, so it will just fail your deployment straight away. Link servers within some procs didn't exist in the target server. So they are out there, people do use them, so we have to come around some of these issues like that. And some useful indexes didn't exist for querying. So if you know there's a table in there that they've just done a heap on, and you know an index is going to improve it, how do you get that on that table? So this is pretty much the rest of the session, the demo. If you have any questions, just please ask. So this is it here. So I've just used AdventureWorks as a demo. On AdventureWorks, we have our source database and our target database. All I'm going to do is I'm going to drop them and recreate one of the databases. So there's no smoke and mirrors. Does anyone use like any other tools like dbGhost, Redgate, or anything other for database deployments? I know Alex does. There we go. Right. So on your left-hand side, you can now see that we have just the AdventureWorks source database. Then what we want to do is we want to grab whatever's in that database. So imagine this is in a different data center. We're going to grab it, and it's going to create a DAC pack. So that's one of the first steps that we do. So we change the directory. And this is the built-in functionality of SSDT or the SQL package.exe. So this is all it's doing is it's going to my local server. It knows that the AdventureWorks database source is there, so it's extracting the schema, extracting the database. It's going to resolve some reference issues, and then it creates this DAC pack. So if we go into our code, so this is what it's created. And what we'll do is we'll go into the DAC pack. So if you didn't know, a DAC pack is basically a zip file. You can change the extension to .zip and go in, inspect it. Oh, got sound on. Yeah. And there's two important things on this. The content types just tells you what is inside of this file. So there's a lot of text files and XML. If there were SQL files, it would say like text SQL. The DAC metadata I've never found really useful. This is one of the important parts, is the origin. I think I might need to again zoom it. Just go back. So the origin file is quite important. Once people find out that you can change a file to .zip and you can mess around with the model, people think that it's good to just like rezip it and then go off and do what you like with it. There is a checksum in here that Microsoft check first to say they actually grab the model XML and they checksum it. And what I'm doing is I'm just doing the same thing that they did. And they say that this should be the checksum. If you go in and alter the model, repackage it up, the first thing that it will check is, do the checksums match? If they don't, it just fails. So this is quite important because we're going to be altering the model. It's like a fail-safe as well. It's quite good. It catches quite a lot of people out. And the other part of it is the actual model. Oops. So here we are just saying this is what the database actually looks like. So it basically creates elements for every object in there. So if you have a table, you'll see SQL table. If you have a view, SQL view, the default constraints, any indexes, these all get added into this. And this is what people try and fiddle around with to get around things. But essentially what we're doing to move all of this data over is that we are not interested in the stored procs, the views, the functions. We're only interested in the underlying tables. But there were some things that they were interested in. So this is where you kind of need to write your own program. So I've created a program. It's on GitHub on DACpack. And then all we do is we pass in some parameters to say, I want to strip these objects out of the DACpack. And if you run this, oh, is it that? So there's just some inputs here. So all we're saying is that this utility is quite small, lightweight. We have an input. So the input is the DACpack. We want elements to remove. So when you look inside of your DACpack, we're essentially saying that what we want to remove is an element by this name. Does that make sense? And then we have properties as well. So properties within the DACpack will be something like an identity property to say this table, this column is an identity column. I've had to strip some of those out as well because I didn't want to set identity insert on for quite a lot of the tables. So imagine you have like 1,000 tables to look after. You don't want to be setting identity insert on. So what you'll see is, if you look for a table, it has all your properties within there. So we can see that ANSI nulls is on. This is how we say this is a simple column. So a simple column is a built-in column. And then this would be a property here. So we can say remove as nullable, but we wouldn't want to do that. We only want to do it in certain situations and certain clients. Yeah, we have string replace. The string, so the custom part is adding custom parts to the model XML file. Must be valid XML elements. So you can import multiple files. This is the part to the index reference. So you know a table should have an index on, but someone somewhere down the line hasn't added it. We can inject it into our data warehouse. We have custom parts. The custom parts I just said. The string replacement. This is mainly to get around the link servers. So you have 4 part names for link servers in SQL Server. You just find that link server name, and it will strip it out, and you're left with the 3 part name. You can remove elements by type and name. So if you know the name of the SQL table, but you don't want to get rid of all the tables, you can just specify that I only want that table removed because it's garbage. And at the same time, we can keep element types and names. So if you strip out a load of stored procedures, but there's this one special one that no one knows about, you come your year-end or quarterly reports that you need that procedure to decrypt something, you can keep it in there and it'll keep it for you. And then there's just a verbose mode and a help command. But the code I've tried keeping quite simple. So this is the actual source code for this project. We pass in these arguments. It just does some error checking. Then we want to remove add elements, or we just want to remove elements. And this is essentially what you do. You open up the DAC pack. So remember how I just turned the DAC pack into a zip? This is doing the same thing. We're just using a package helper to open that DAC pack, and then it has these URI elements in there. So we had a look at that origin because we need to change the checksum, and we have the model. Then you get these package parts, and then they're just XML documents. So I've used xdoc and the namespace. And then if the checksum doesn't exist, or if it does exist, we're just going to change it. It's quite true for everything mainly. Can everyone see that, or do you need me to zoom? You can see that? So there is an order to how we keep things. So we're going to keep some elements. So that the first part is that it comes along and it scans for the keep elements part. So we're going to keep objects that we're interested in. Then it comes along and it looks for properties, but it does the elements as well. So this is the whole gist of it here. Is that link query. It says get the root descendants where the attribute type equals the names that we're passing in, and just remove. It does the same for the properties. So we're just passing in delimited strings. You can do the same for remove element types. And then we need to reset the stream because it just does something weird. That's the string replace. So we have to turn it into a string. Then you can see what's going on. It's replacing it using the string functions within C#. Then we have to rewrite that stuff as well. But if you want to add new parts, this is the part that does the adding. So I'll show you that at the last part. And then we save that in, and this is where it does the byte array. So the byte array is something that Gert Draper's give me. He's the actual creator of this project. Well, he's the creator of DACFX. So he kindly gave me this, and this is what they're doing. So to generate that string that Microsoft come along and check, he's give me that. And then all I do is I turn it into a readable array, and then insert that into the DAC pack. And then we save it down here and close it. So pretty simple. Oops, wrong one. Right, so the first one is, can we get it working as normal? for AdventureWorks, it obviously does work. So you can see here that there is the source database, there is no target database. So all we're going to do is run a simple command, and this is the built-in stuff that Microsoft give you at the door. So we're going to run this. He says, come on. There we go. So this is using the SQL package utility. All we're doing is we're calling that package utility. We're saying action is publish. The TSN is the server name, target server name. Target database name is TDN. And the source file, which is the one that we've just extracted, is that. So there's no fancy widgetry stuff going on here. This is just the Microsoft out-of-the-box stuff that you get. If your stuff works like this, great. You don't have to do anything. You don't have to come in, strip the DAC pack or anything. There we go. Takes a minute. So that's it. Took, what, a minute or less just to deploy all of that. And then if you run it again, there should be no changes. So it comes along, it looks at the DAC pack, it's working out what's the differences. If there are any differences, this is what you see above. But there shouldn't be any differences, so we should just see that. So you can see that there is nothing to actually do. And then if we look in our target database, we can now see that there is a target database there. And it has everything in there that we have in the source database. We've not manipulated it in any way. But this is the part where it didn't quite work for us because there were these rogue objects in there. This just bottoms out as soon as you start trying to do stuff like that. Yeah, so we came along, we wrote the utility. And then remember when I went into the DAC pack, I've said, so this is just that exe that we're using. This is the source DAC pack that we're going to overwrite. These are the elements that we're going to remove. So we're going to remove foreign key constraints and extended properties. Question?
This DAC pack, does that also take the data, or is it just the structure?
So the question is, does the DAC pack take the data or just the structure? So a good question. So the DAC pack only takes the structure. There is something else called a backpack that you can extract data. So a backpack will extract data and it puts it in a JSON format. There's something with the current client that I'm using that they only want to back up certain tables. So as a fudge, we back up using a backpack, and there's about 5 tables that we just take a backup of. So we specify which tables that we want, because all the other stuff is just garbage that we're not interested in. But yeah, you can do the same. You can create a backpack, but I'm not doing this for this. And there are issues around that if you have huge amounts of data. So everyone's view of huge data is different. So imagine sending out 1 billion emails a day. You're not going to take a backpack of that. We're going to monitor it properly and like move things over in chunks. But yeah, so if you want, backpack is schema only. Backpack will do schema and data. Good question. So for this, I'm taking out the foreign key constraints because luckily whoever designed the system in the first place put proper constraints in there. And when you're loading stuff into a staging area, we're not really bothered which order it comes in. So the next part of it, which I'm not doing the demo on, is that we used Service Broker to fire off. So we had 64 cores on every machine that we had. We fired off 30 threads, and it would just keep pulling the data, but it would be 30 threads at a time. And we're roughly getting, I clocked it at like 980,000 record inserts a second. So when we had big pushes, the data would be there within 5 minutes, but any structure changes were always 15 minutes after. And then when you come to do your data warehousing, you're doing inner joins anyway. So you're not interested in, well, you know, such and such hasn't arrived at that time because it'll get picked up at a later time. So just removing the foreign key constraints and extended properties. Excuse me. Why isn't that working? So this is taking that adventure source backpack and it's stripping out parts of it. That bit is really quick. Remember the checksum? So that checksum exists already. But now that we've changed the model, we need to regenerate that checksum. So that calculated section gets reinserted or overridden. And then when we come to do the deploy, so it's still working out. And we can see that it's pretty much dropped everything that we didn't want. And to prove that, you can go into the target and the source. So this is the source database. If you look on the AWV, the AW build version in the source, we have an extended property. So the current version, this is what Microsoft do on the AdventureWorks. Then if you look in the target, you should see that we don't have the extended property anymore. So no extended property, it's done what I wanted it to do. It's an interesting way of modeling databases, because I've had another need for another client where they sharded databases. So imagine you have AdventureWorks and you have your schemas on the left. So you have human resources, person, etc., employees. They actually think of that, they strip them out into different databases. But when you come to do your data warehouse, you need to put that back together. But if they're already using SSDT, you can use a similar version to this, but you build a DAC pack. And I've done that for one client, which is quite interesting. And we've done it on like a product shelf. So you say, like Amazon do the same thing, you know, when you're looking at the top of their ribbon and it's like you want department stores, videos, etc., etc. You essentially pick what you want. So we want to build a data warehouse that has human resources and persons, and then you just tell it what you want out of it, and it goes off and it does a similar thing, but it's just doing the insert stuff. So it's taking the parts that it wants, building it, generating a checksum, and goes off and deploys it. It's an interesting way of doing it. And then on here, so for the employee, we can see that there's no foreign key constraint in there. And then in the source database, we can see that there is a foreign key in there. So we've just stripped out all foreign keys, all extended properties. And then the other one that we do is that we actually insert, we're inserting an index into this table. So we can see on the AW version that we have these indexes. So they only have one index. This is just an example. But we want to add an index onto the version number so we can get the latest one pretty quick. Then what you do is you create a small project, like a little test project, and you create that table how you want it, and you find that element that you want. And then you essentially, you drag that piece out, put it in a separate file. So you can see how it follows the modeling convention. And this is the element part that we're going to actually insert into the database. We're going to say, insert this index on this column. But remember how many objects we had and how many databases. So you don't want to do that across 529 databases manually. You want to get something automated. And this is essentially what this command does. So it's saying still remove the foreign keys, still remove the extended properties. And just to make sure that there's still no smoking mirrors, I'll re-extract the database for you. And what we're going to do is we're going to insert that element into this source database. Oh, come on. So that's done the manipulation. And then this is just going to go off, figure out what it needs to do again, and deploy those changes. So you can see that we've just added the index that we wanted. So you'll see this is a source database, I believe. There is no index there. Someone's missed it off. But what we want to do in the staging area of our data warehouse is that we want that index there. So if we refresh this, we can see that we've injected the index, and it's gone off, and it's done it across all of these databases for us. And with that is pretty much the end of the presentation.